Okay, in this section we're talking about rational and quadratic inequalities. And at first glance you'd think, why on earth would we have to go through all of these 5 processes in order to solve this inequality? Surely there's an easier way than that, but really there's not. And so the reason we have to go through this 5-step process is for this reason. A lot of people think that you can just set the first piece equal to 0, in this case greater than 0, and the second piece greater than 0, and that would solve out this particular inequality. But it doesn't. And so you have to consider all cases. So when we think about this, I'm looking for something in this little makeshift problem I threw up here. I'm looking for something that's greater than 0. Well, I know that if this part is positive, if it's greater than 0, and if this piece is positive, if it's greater than 0, well, 2 positives would definitely be greater than 0. But there's also another case. What else is positive or greater than 0? And that would be 2 negatives. So you also have to take into consideration if the first factor is negative and the second factor is negative, that would give you a positive result. And of course a positive result is greater than or equal to 0. So that's why you have to go through all these cases. You can't just say, oh, 2 positives would give me a positive. Although that's true, there's something else that would give you a positive result as well. And that's why we need to go through these cases. So let's start one. I ask you to solve the inequalities and write your answer in interval notation. My problem looks like this. Okay? So the first step, it says make sure that it's in standard form, make sure it's factored with the right-hand side 0. Okay, so I need to move my 2x over. When I move the 2x over, it changes signs. I'm also going to put it in descending order. Okay. When the 2x comes over, it changes signs, and I put it in the middle so that I could factor it. Okay, this is an easy trinomial. The factors of 3 that subtract to give me 2 are 3 and 1. And this is how it looks. And this is the end of step 1. Okay, step 2 says find the zeros of the numerator and denominator. So in other words, we're going to set our numerator equal to 0, and we're going to set our denominator equal to 0. There's no denominator, so I don't have to worry about that here. So the numerator is an x minus 3. I'll set that to 0. The other factor is x plus 1. I'll set that to 0. So when I solve this one out, move the 3 over, I would get a positive 3, and move this 1 over, and I would get an x equals negative 1. Now those are my zeros. Okay, before I go any further, I want to talk about brackets and parentheses. Here's your rule. If it comes from the denominator, it will always use a parenthesis. If it comes from the denominator, it will always use a parenthesis. Now this one didn't have a denominator, I know, but I just want to go ahead and get in that habit. The numerator depends. The symbol here depends upon the problem. Look back at the original problem. You'll see that you use this symbol. See how it used this symbol? I put a green heart around it. This symbol here takes a bracket. So your numerator will always depend upon the sign in the problem. If it has a little bar under it, it takes a bracket. If it doesn't have a bar under it, it takes parentheses. So that is the end of step 2. Step 3 says put these numbers on the number line, dividing the number line into intervals, and name the intervals. Okay, so this is a number line that goes from negative infinity to infinity. I need to put the numbers -1 and 3 on the number line. It doesn't have to be, they do not have to be perfectly placed, but they do have to be in order. Of course, -1 comes before 3 on a number line. You'll notice it also said name the intervals. So this interval here, starts at negative infinity and it goes to -1. Well, if you look back at that step 2, it says that -1 is going to use a bracket. In the middle, this interval goes from -1 to 3. -1 takes a bracket, 3 takes a bracket. Going back to this step here, that's how I knew it was a bracket. And lastly, this one goes from 3 to infinity. Remember, infinity takes parentheses. So that's step 3. Step 4 says, choose a number from each interval. Okay, so a number out here that I could choose would be -2. A number in here I could choose would be +2. And a number over here I could choose is 4. Any number in that interval would work. Lastly, you're going to construct a true-false chart. Now, look back at the red star. So what we need to do with this red star is we're going to take the -2 and the 2 and the 4 and we're going to plug them into this statement. And we're going to see, is it true or false? So, if I take -2, that's the end of step 1, plug it into the end of step 1, I would get -2 minus 3, -2 plus 1, and I want to see if that's greater than 0. Okay. -2 minus 3 is a -5. -2 plus 1 is a -1. Two negatives make a +5. Is +5 more than 0? Yes. That means that's a true statement. That means this interval here is true. Okay, so we're going to do the same thing with the number 2. Plug that into our red step. So we have 2 minus 3, 2 plus 1, and I want to see, is that greater than or equal to 0? So that's -1 times 3 is -3 more than 0? No, that's false. So then we'll do our last one. That's the number 4. Plug 4 into the red step. So that's 4 minus 3, which is 1. 4 plus 1 is 5. Is 5 more than 0? Yes. So that's true. Now, all that work is useless if you don't know which one to choose. So, what you have to do is pick true. Only pick the true statements. It's not going to be 3 answers. Only pick the true statements. So this one is true, and this one is true. So your answer is -infinity to -1 with a bracket, union 3 to infinity.